Hi, my name is Daniel Chu, and my partners are David Gonzalez and Quang Nguyen. Today we will be talking about Gustafson's Law. We will provide some background on who John Gustafson is, what his law states, and how it contrasts to another law called Amdahl's Law. We will also be talking about its practice in research and how to apply it in computer systems.
Gustafson Law was named after John Gustafson. John Gustafson is an American computer scientist and a businessman. He's known for his work in high-performance computing. He helped introduce the first commercial computer cluster. He's presently the director of Intel Labs at South Carolina. Uh, he also received several awards for computer speed up.
Now, what is the Gustafson's Law? Okay, the Gustafson's Law is pretty much a response to Amdahl's Law on the limitation of effectiveness of parallel computing due to a serial non-parallelized component of code. Gustafson's law was developed to show that you can achieve over 1,000-fold speedup using 1,024 processors. It states that if the size of most problems is increased sufficiently, you can achieve any given efficiency by increasing the amount of processors. Okay, now let's go ahead and look into a graphical view of Gustafson's law, just so we could get a better idea of what he's trying to tell us. Okay, and then there's the graph. As you can see, every line is the addition of a processor, and as you can see, the slope uh, would the slope increases as you add processors, meaning you gain more speed as you add processors, and there doesn't seem to be a limit as far as how fast you can go once you add processors, which is the main idea of the Gustafson's law. Okay, now let's briefly talk about Amdahl's law, which was the law that would reign before this Gustafson's law uh, was accepted. Okay, Amdahl's law used to govern the speed up of using parallel processors on a problem versus using only one serial processor. It is often used in parallel computing to predict the theoretical maximum speedup using multiple processors. In computer programming, Amdahl's law states that in a program with parallel processing, a relatively few instructions that have to be performed in sequence will have a limiting factor on program speedup such that adding more processors may not make the program run faster. This is generally an argument against parallel processing for certain applications and, in general, against overstated claims for parallel computing. Now let's take a look at a graphical view of Amdahl's law. As you can see, the different color lines, they show the addition of processors as well. But as you can see, even though we do achieve more uh, higher speed up as we add processors, there is a clear limit as to how fast the computing could be done as you add processors. So and now let's go ahead and look at them next to each other and compare them. So you can see, we can see the same trend between the two graphs of adding a processor and achieving more speed. But one law, which is the Gustafson's law, clearly states that there is no limit as you add processors. It just becomes faster and faster. Now let's go ahead and use that driving metaphor just to make things a little clearer. Amdahl's law would suggest that if you're driving a car that is traveling between two cities 60 miles apart and has already spent 1 hour traveling half distance at 30 miles per hour, no matter how fast you drive for the last half, it is impossible to achieve 90 miles per hour average before reaching the second city, since it has already taken you 1 hour and you only have a distance of 60 miles total. going infinitely fast would only achieve 60 miles per hour. So clearly in this example, I'm just letting you know that there's a limit of the speed that it could take me from going to point A to point B if I have been going at a certain speed, between those 2 points. On the other hand, Gustafson's law would suggest that if you're driving that same car and you've been traveling for some time, let's say at 90 miles per hour, given enough time and distance to travel, your car's average speed could always eventually reach 90 miles per hour, right? Which was the speed that you were traveling before you got to that point. No matter how long or how slowly it has already traveled. For example, if the car spent 1 hour at 30 miles per hour, it could achieve this by driving at 120 miles per hour for 2 additional hours, or at 150 miles per hour for an hour, and so on. So it's letting you know that if at a certain point of your travel you want to go faster, you could. So it's a simple way of contrasting the two laws. But let's go ahead and just see how in computer science um, this law is more clearly defined. Okay, so Gustafson's law in computer science would be a law which states that large problems with repetitive data can be efficiently parallelized. Gustafson's law contradicts Amdahl's law, which describes a limit on the speed up that parallelization can provide. Amdahl's law reveals a limitation, for example, the ability of multiple cores to reduce the time that it takes for a computer to boot to its operating system and be ready to use. Assuming the boot process was mostly parallel, quadrupling computing power on a system that took 1 minute to load might reduce the boot time just just over 15 seconds, right? But greater and greater parallelization would eventually fail to make boot up go any faster if any part of the boot process were inherently sequential, not parallel. Gustafson's law argues that a fourfold increase in computing power would lead instead to a similar increase in expectations of what the system will be capable of doing. If the 1 minute load time is acceptable to most users, then that is a starting point from which to increase the features and functions of the system. The time taken to boot to the operating system will be the same, right? So it still could take you 1 minute to boot up your system, but the new system would include more graphical or user-friendly features. So see, as we take a look at this last paragraph here, it would be clear to say that both theories have actually things in common, but Gustafson is pretty much letting us know that if we could increase the number of processors, your speed up, your boot up time, for you to get to your Apple operating system or to your Windows operating system will be the same. But what you can do with this increase in processing power is enhance the features. So this could allow, for instance, Windows to come up with a better operating system that requires more at the time of boot up. Now, the when you add more processors to a computer, doesn't mean that the boot up process is going to be faster, but that it will be faster to process other things such as graphics, other applications. Let's say if you have to type your security code, any additional features could be made faster by adding this processor. So there is really no limit. You just have to see what type of problems, what type of parallelized problems uh, you could tackle when you add multiple processors. Okay, and I'm gonna go ahead and turn it back to Daniel for the conclusion and the works cited that we use for this presentation. Thank you.
So, today, you've heard about Gustafson's law and what it is, which is basically that it is a law in computer science which says that computations involving arbitrarily large data sets can be efficiently parallelized. So what does that mean? Well, the impact that his law had was to shift research goals to select or reformulate problems so that solving a larger problem in the same amount of time would be possible. So in a way, the law redefines efficiency due to the possibility that limitations imposed by the sequential part of a program may be countered by increasing the total amount of computation.